Hello, so today we're going to do a literal advanced equation, and we're going to use as an example a very infamous equation of state in physical chemistry known as the Redlich-Kwong equation of state, which was an empirically derived equation of state that corrected mostly basically focused on correcting the eighth molecular attraction constant. And this was developed, I think, around 100 years after the theoretically derived van der Waals equation of state that most of us know from general chemistry. So today we're going to work on this, and let's start. So let's start by solving for A, the attraction molecular constant. And so we're going to say, okay, so what do? We're going to first divide both sides by V bar minus B. V bar referring to this V with the line above it. So we're going to say, okay, so P plus A over square root of T V bar times V bar plus B equals RT over V bar minus B. And then we're going to subtract P from both sides and in order to isolate the term with the A constant. And so this becomes A over square root of T V bar times V bar plus B equals RT over V bar minus B minus P. And then last but not least, we just multiply both sides by the denominator in the left-hand side of this equation to isolate A. So multiply times square root of T V bar times V bar plus B, and then this basically ends up being RT over V bar minus B times the square root of T V bar parentheses V bar plus B parentheses close parentheses minus P square root of T V bar plus B. And in order to combine these two terms, because this is one term, another term separated by this minus sign, we're gonna have to use just a common denominator, and this is easy because all we have to do is multiply times V bar minus B over V bar minus B on this side in order to arrive at this common denominator of V bar minus B, which the left-hand term has in this equation. And so then in that case, then this is gonna, I'm gonna scroll down because of space. This would reduce to A equals RT square root of T V bar times V bar plus B minus P square root of T V bar times V bar plus B times V bar minus B all over V bar minus B. And from here on, we can further simplify this by, let me just look at my notes to make sure I'm doing this correctly. So yes, that looks about right. Okay, perfect. So now what we want to do is now on this numerator, extract the common part that can be found in both of those terms in this numerator. And in this case, it would have to be, well, we have a square root of T, we have a V bar, and we have a V bar plus B. So we can extract that from both sides of that numerator section. And then all we have to do is put big brackets and say, okay, the rest, just put everything else that goes in so that it would equal this numerator right here. So in this case, it would have to be RT, and then here would be minus P and times V bar minus B. And then all over, let me finish drawing this line, V bar minus B, and then further simplified, this would be okay, yes, that's correct. I'm just looking at my notes. So the answer would have to be the square root of T V bar times V bar plus B, and then times RT. I'm just going to expand that using distributive property. So minus P V bar plus PB, or we can say little p B, same thing. And then all over V bar minus P. And this would be the results for our A parameter constant in here. So let me make sure that looks correct. Perfect. So now let's say that they ask us for part 2, let's say, of this question, to solve for the B coefficient. And it's a bit more tricky because unlike A, B is found in 2 sections of the left-hand side of this equation. And so it's going to involve, as you can see, some more algebra, but nothing impossible that we cannot do, right, using the algebra information we know. So let's rewrite the not van der Waal, but rather the Redlich-Kwong equation of state, so we're on the same page. And I'm going to write it again. So it's P plus A over, okay, let me redo that, yep, and square root of T V bar plus B, all of that multiplied times V bar minus B equaling RT. Okay, so yes, solve for B. So let's start by, let's see, we want to get rid of, no, first we need to distribute that V bar minus B to both sides because that's the only logical thing we can do. We have to start somewhere, and the only thing we can start in terms of doing some algebra here is that seems logical would be to just simply distribute that V bar minus B to both of both of these terms inside that parentheses. So let's go ahead and do that. And so when we distribute this term in here to the P and to this term, then it's going to result in PV bar minus PB, then plus A times V bar minus B all over the square root, all over the square root. I'm trying to draw a decent line here, but I can't. Okay, right there. So over the square root of T times V bar times V bar plus B, and then equaling RT. Okay, so let me see. From here, we can further distribute that the numerator right there, and that is exactly what we're going to do. So PV bar minus PB plus AV bar all over, as you can see, like the main gist of this is just like expanding the equation until we can see some form that we can somehow algebraically simplify. So we're just going to continue distributing everything we're seeing. And so this term right here is really AV bar minus AB. And when you have 2 things over a common denominator, it's the same thing as doing this right here. So that's exactly what we're doing here in this algebraic manipulation. So this would be minus AB over square root of T V bar times V bar plus B equals RT. So this is just an aside. Okay, so now so now let's see what we can do. We want to solve for B. Well, now here, I think it's where we have to kind of, let me just look at my notes really quickly. Okay. Okay. So what we want to do here is go ahead and reduce. This is expanding, and now we're going to just see what we can cancel out. And these 2 V bars cancel out because we have a V bar here in the numerator and denominator. So then from there, we can simplify by now making all the terms have a common denominator on the left-hand side of this equation, not the right-hand side, because we'll get to that later. So let's make them all have a common denominator, and in order to do that, we're going to have to multiply this PV bar times whatever is left here. So we're gonna stick with this one as a common denominator. I believe that's what we should do. So then this would all become TV bar. I'm gonna write a little bit smaller because I have the feeling I'm gonna run out of room really quickly. I'll just make the pen smaller. Let's see what works better. So then this is square root of T v bar plus b over this. I'm just going to redo the same thing because it's basically, you're not changing the equation, you're just multiplying basically by 1, but that 1 being in the form of the denominator, common denominator being the thing established here. So then that is equal, okay, sorry, and then plus a over square root of t v bar plus b. Since, okay, I was about to sneeze and now I'm not gonna sneeze. Okay, so sorry about that. Continuing on, we canceled that v bar, so that v bar is not gonna be there anymore. So we have to have it here as well, so that it's in that sense it still reduces to what we already decided it was going to reduce to by simplifying and canceling that v bar in the numerator and denominator. But we're just gonna, since we want to have a common denominator still, we're just gonna simply add that v bar back in there. So I guess it wasn't time to actually cancel, but we can do that later. I'm just gonna look at my notes to make sure we're doing this correctly. Right, exactly, it wasn't time to cancel yet because we still wanted to have a common denominator, and if these two already had one, it wasn't logical to have canceled this early on. So we just got back to stage 1 in that sense, and we're going to continue writing this expression. AB, okay, I think I'm running a bit out of space, so I'm going to write a bit smaller. Square root of t v bar plus b, okay, perfect, equals RT. So here we have everything with a common denominator. After having distributed everything that was possible to distribute, then we decided, okay, let's have a common denominator. From here on, I think we are going to want to see some kind of simplification. Okay, so I'm just going to look at my notes. And what did I do here? Right, okay, yes. So one thing is that since we have the common denominator, we can add all these terms on the numerator and then divide it by that common denominator. And that's exactly what we're going to do. I'm just like trying to see how I simplified it so that I don't have to write a lot of steps here and just kind of walk the logic through, but just write the results. So basically what we're going to do is start by writing the numerators on these two terms because I know why. So negative AB plus AV bar. And then the reason I said I know why was because now on this side, we have the same thing on the numerator. And so we're just kind of rewrite that as in this way. So we're going to have square root of t v bar times v bar plus b, and all of that is going to be multiplied times pv bar minus pb. And so in that way, it's like kind of rewriting it in the way that undoing that distribution that we did so that it's now more concise, more compact instead of rewriting everything. And then of course, now we're gonna divide everything by that common denominator. And so let me make sure that's what I did here. And yes, that's exactly what I did. Perfect. So now I'm going to divide by that common denominator. Okay, I feel like I'm running out of room. Let me try to draw the line closer to the terms. Okay, so then that's square root t v bar times v bar plus b, and then that equals RT. Perfect. So I'm gonna move this down so we have more space. And so yeah, that's a very important result. From there on, guess what we can do? Well, we can get rid of this common denominator on both sides because we don't like fractions. We're going to multiply both sides by that common denominator. And I know from this point, it just seems like me guiding you because the logic is kind of, it's like it takes a bit of steps to get to this point. So just bear with me and follow through, and then you'll see at the end you can redo it and it will make more sense. So now we're going to multiply both sides by the denominator to get rid of that fraction, in other words. So we're going to multiply both sides by that denominator. So then we end up with negative AB plus AV bar. Okay, I just noticed that I am writing over my screen there, but that's basically what I put here was the denominator that's here. So with that in mind, I'm going to continue. So plus the square root of t v bar times v bar plus b times p v bar minus pb, and then equals rt times what we said we were going to multiply here, which is that the denominator here, and that is square root of t v bar times v bar plus b, close parentheses, close parentheses. So from here on, I'm going to check my notes to see how I proceeded. Right. RT. Yes, that's correct. I did that later on in my derivation, in my simplification here, but it's okay to have done it this early. It actually will make it a bit more cleaner, to be honest, so that's okay. So now what we're going to want to do is focus on the left-hand side. Forget about the right-hand side of this equation right now. So what we want to do is kind of combine these terms once again, and then because it's going to result in the infamous quadratic form equation. Well, not the quadratic equation solved for x, but rather like the quadratic form of ax squared plus bx plus c, and so equaling a constant, which in this case is going to be everything that ends up on the right hand side. So that's kind of the logic up to this point, and I guess this step along with the one before are kind of the, well, really this step, but the more you think about it, it kind of just really makes sense to do it this way. So we're going to simplify the left hand side and redistribute everything we have here. And I'm just going to make sure that's what I did. And yes, so how about we start by distributing this first. So negative AB plus AV, oh, this should be V bar. Sorry about that. So this should be then square root of t v bar times v bar. Well, that's just v bar squared. And then plus square root of t v bar b. And then all of that has to be multiplied times p bar b minus pv bar minus pb. And then again, this is just, I'm just going to write this, and it just means all of that again here. It's just it's no common notation, just so that I don't have to write the right hand side. So then from here we now will treat this as where we do cross multiply, we do distributive property here, and then we distribute that one to this one. So basic algebra right here, but just with, I guess, more complicated terms than what we're used to in algebra 1. So negative AB plus AB bar. So here, I'm just going to draw a big bracket so I know that it has to do with these two terms being multiplied. So I'm going to say square root of t p v bar cubed. That's like this one here. And then I'm going to do plus that. And since there's a minus, then it has to be a minus. Minus pb square root of t v bar squared. And then I kind of want to get rid of this because we don't need it anymore. Okay. And then now we're gonna finish off by distributing this term to these other two terms. So that would be plus p square root of t v bar squared b, and then minus, because we have again the same minus in front of that pv term, minus p b squared square root of t v bar, and then close bracket. And then again, I'm just not going to rewrite that because it's just redundant. I'm just going to put those. And so here, now let's try to simplify this. If we can see, these two terms right here are exactly the same, with the difference that one is negative and the other one is positive. It's just arranged in a different way, but it's still the same terms. And so we will easily cancel those out because that will simplify everything. And we're going to rewrite this. So negative AB, I'm going to write a bit more here. Okay, perfect. Negative AB plus AV bar plus the square root of T PV cubed minus PB squared square root of TV bar equals that, the right hand side of this equation. So again, now this is a point where we want to take advantage of the ax squared plus bx plus c equaling a constant quadratic form. And I'm just going to write it here as an aside. That is ax squared plus bx plus c equals a constant. Usually we say 0, but yeah. And so, right. Well, it has to equal 0, sorry. That constant on this right-hand side ends up being the minus part. We have to subtract it from both sides, so it's that part of that c part of the constant. And so here, I'm going to just quickly signify, we have a b here. Then we have a b squared term here, and everything else does not have a b. And so, let me make sure I'm correct about that. Actually, that right-hand side does have that b term. So let me look at my notes and see what I did. Right, okay. So first, I subtracted, correct. Yes, we can't neglect that right-hand side. So this right-hand side right here is still the same one here. That's why I was just drawing those dashes. But now what we're going to do is subtract this side from the right hand, so it ends up on the left-hand side. And because of the logic that I just explained. So I'm going to erase that. And I'm going to rewrite. I'm going to, subtract that. So then we're going to keep this the same. And we're going to subtract this RT square root of T V bar times V bar plus B term. And so, and that all equals 0. So here we're going to want to distribute this, this right here, right? So first we would distribute this, and once this is one term, we distribute that into that term, right? So let me make sure that I'm doing that correctly. Right, that's exactly what I did there. So I'm gonna scroll down a bit. I wish this program would have like the rearrange, but it doesn't have that option to rearrange what I've drawn here, so I just have to stick with the space available. But hopefully y'all still understand. Sorry about that. Okay, so I'm just rewriting this, and then minus RT. Okay, so yeah, so I'm gonna put big brackets, and I'm gonna say square root of T V bar squared plus square root of T V bar B. And then again, I'm gonna now distribute that to that newly formed term. And so then that becomes negative AB plus AB bar plus square root of T PV bar cubed minus PB squared square root of TV bar minus R T square root of T. T times square root of T is T times t to the half, which is t to the 1 plus 1 half, which is t to the 3 halves. So using exponent rules, we arrive at that. And then that v bar squared is just carried over. And then we have minus r, again, t to the 3 halves, and then v bar b equaling 0. So that sounds about right. And now we can try to see, okay, how can I make this result that we've arrived at analogous to the ax squared plus bx plus c equaling 0 quadratic form. And so we're gonna circle everywhere we see a b squared. So I'm gonna use another color, and I accidentally made my brush size bigger, but I'm gonna correct that right now. 2.6 right there. So then let's use red. Well, this red is kind of intense. Well, let's try. So we have this b squared term here, okay, which corresponds to that x squared term in the general quadratic form. And then we see, okay, because again, we want to solve for b, so that's fine. If we wanted to solve for v bar, I think we could, but yeah, we could actually. But anyways, b squared, since we're solving for b squared, that's like the x of that quadratic form. So that's the only place here that I see a b squared, so that's why I'm going to do that. And then now let's look for anywhere we see the b term, which is this one, right? So that x term. So b, where do I see? Well, I see it here, and I see it here, and nowhere else, meaning the c term. Okay, I accidentally again increased the size of the pen. Bear with me, please. 2.6, please. 2.6. Oh goodness, okay, there. And then let's do with okay, I have purple left, so I'm gonna choose purple. That c term right there, okay, I think that's not easy to see. Let me choose a darker color because okay, yeah, that's a darker color. So orange, we're gonna use for c to denote c. Oh, it's still pretty light. Give me 1 second, or let's just use a dark green. Okay. So dark green for C, perfect. That's easier to see. Everything else that does not have a B is part of that constant C. And this kind of algebraic manipulation is not exclusive to this equation of state that we're using to solve for algebra practice. This type of manipulation is seen all over the place, like in kinematics, where you want to find time in 2 dimensions, and an object that is kinematically moving in 2 dimensions. There is an application where you can use that to find time, the quadratic formula, and you can see it here in physical chemistry for this equation of state, and other places I've used it, I just can't remember. But yeah, so it is useful, so that's what we're going over it. And so I'm going to circle these 2 terms as part of that C, as well as these 2 terms, because they do not contain the B, which is the independent variable in this case that we want to solve for. So with that done, we're going to go back to using black, and now we're going to rearrange it so that it's in that order. So we're going to start with negative pb squared square root of t v bar, and then we have minus ab plus v bar b, and then plus av bar plus av bar, and then plus square root of t p pv cubed, and then minus r t to the 3 halves v bar squared minus rt to the 3 halves. Oh, okay, I just noticed I did a little mistake when I circled the terms here. My apologies. This should not be, so let me make it smaller. This is not part of that constant part, because this is actually connected multiplied times the v bar. So this green ends right there. So let me correct that once more. Sorry about that. This should end, okay. This should end right here. And then this blue part, I'm just gonna delete that b bar. I'm gonna rewrite it back there. V bar b. And now this is part of this entire thing with the minus sign in front, is part of that x term. And right, this makes more sense. So negative p v bar, negative pb squared, yes, which contains the x squared root of g. Then we say minus ab, right, because that contains ab, and the other only term in this polynomial that contains b is this one right here. So then I'm going to, since I can't move the terms in this program software, I'm going to have to rewrite it. So bear with me. We're getting close to the end, so sorry about that. Okay, so negative pb squared square root 2v bar minus ab. Okay, and let's get back to, okay, so minus ab minus rt to the 3/2 v bar b. And now rewrite everything else. Plus ab bar plus square root of t p v bar cubed, and last but not least minus rt to the 3/2 v bar squared. So just to denote again, this is our c part of the term. This would be part of the x squared part of, and this would be the x itself, right? The ax squared, should we say, the bx, and then that c term. So let me make sure that this is correct according to my notes. So yes, and then and then plus ab plus square root t q minus rt. Yep. Oh, right, and of course, do not forget this is an equation that is set equal to 0, right? And so just quickly before we proceed and apply the quadratic formula to solve for b, we're gonna distribute that b, because we want it to be b times everything else, right, within that bx term, because otherwise it's going to be kind of weird to do this. So negative pb squared square root of tv bar, and all we're going to do is just get that b. I'm going to use big parentheses to make this obvious, so this should be plus rt to the 3/2 b bar. And okay, so what I did is, this is correct algebraically, but I decided to do it a different way. But I kind of really like this way, but it's okay. Let's just do it the way I did in the paper, because that way I don't get lost later on. So we're going to do that, and we're going to just say, okay, so this is p, and this would have to be plus, or actually no, that should be, still should be minus, and that should be a minus. But I don't really like that. But I guess if it makes that term be term positive, then I guess that's why I thought it would be easier. Okay, it's okay. We'll do it this way then. And so, again, just add everything else. So plus ab bar plus square root of t p v cubed minus rt to the 3/2 v squared equaling 0. And so right here, now we have everything simplified into the ax squared bx c term. So let's define what is our a. And our a here is going to be everything that is a coefficient in front of that x squared term, which in this case is b squared. So the coefficient for that a would be equal to negative p square root of tb bar. And I'm gonna okay, it seems I did something different. Oh right, okay, This is interesting. So I did that and okay. Right, okay. I guess we can do this. There's no harm in this. So what we're gonna do before we proceed to plug it in and define our ABC coefficients for our quadratic formula, we're gonna divide all of it by the negative p square root t of v bar so that we can isolate that b squared, and that later on it's, I guess, easier to plug in into that quadratic formula. So we're gonna divide everything. Okay, I'm gonna scroll down because I think we're running out of room. Oops, this is the lowest I can go, so I'm just gonna have to delete after, no worries. So then this would be divide this by negative p square root of t v bar. And let me just make sure that's what I did here. Yes, that's what I did. So when you divide every side of this equation by this negative p square root, or should we not do negative p? Because I think I did not do that here. But that doesn't make sense because this was p negative pv squared. So in any case, yeah, to divide, I had to have divided negative p square root of tv bar. Right, okay, I just saw, yeah, I ended up distributing it. Okay, yeah, I have to check myself so I don't do incorrect thinking right here. But yeah, so yes, you divide both by the negative. You want to isolate, so you just have a positive b squared term, which is really similar to that x squared. And then here you're going to do plus b times what we're going to do minus b, because we're going to distribute that right there to that term, and we're just going to put it in front. So minus b times negative a minus rt to the 3/2 v bar, and then over p square root of t v bar. And that's what I did here. Perfect. And last but not least, distribute it to all these signs. And I'm just going to put a parentheses here because we know that's part of that c term. So I'm just going to do all of that over negative p square root tv bar. And again, that negative goes in front of everything because that's the way the algebra works. So av bar plus square root of t pv cubed, pv bar cubed minus rt to the 3/2 v bar squared all over. And I just noticed that I am running over and I can't scroll more down. So just know that I'm only dividing, the only thing you can't see right here, kind of not see, is that I'm dividing by p square root of t v bar, the same thing I divided here, the same thing that's right here. And that negative just got distributed to both in front of these terms right there. And that's why it's right here and right here. Okay, so now, and of course equal to 0. So now we have it in quadratic form. I'm going to erase everything we have. Yeah, I'm going to have to, because otherwise I'm not going to be able to. I don't have any more room. So I'm going to erase everything before. And here we go. So erase all of this. And hopefully this is going to give us enough room to solve. I think it is. So let me see. Let me just go a bit further. Or what I could just do is clear the page. I think that's going to be easier if we just clear the page. Yeah. So I'm going to say file or edit, clear. And now I'm just going to write the result that we had. So the result that we ended up with was b squared. I don't think this is right. I don't know why, but I feel this is a different color. Okay. So b squared minus b times negative a minus rt to the 3/2 v bar, close parentheses, p square root of tv bar, and then minus Okay, AV bar and minus RT to the 3/2 V bar squared plus P square root of T V bar cubed. Correct. And all of that polynomial over the common denominator, I guess, P square root of T V bar. Okay, and of course it equals 0. So we are gonna now plug all of this in into the quadratic formula. I'm gonna recall that the quadratic formula equals negative beta plus or minus the square root of beta squared minus 4 alpha c all over 2 alpha. And it usually goes negative b plus or minus the square root of b squared minus 4ac over 2a. The only reason I'm using beta is because we're trying to solve for b, and b is actually the x right here in this definition, right? So I'm just not trying to confuse y'all and myself, so I'm just going to use beta for b, which is understood for the quadratic formula. So with that in mind, b, now it's just plugging and checking. So I'm going to write really tiny so I can fit this into the page. So b equals the negative b, which is all of this term. So, right. So negative a, but that just reduces to positive a. Right, so what I want to highlight here is if we redistribute this negative sign right here and here, it all turns positive. So because negative times negative is positive, so it would end up being plus b plus plus. And so then negative beta, which is this is the beta part, in front of this b, which is the x, would have to be negative, and then close parentheses all of the what we already have here. And then plus or minus the square root. Okay, let's try to draw this. Right there. So plus or minus the square root of b squared minus 4ac over 2a. So hopefully all of this fits in here. Can only go so far. Okay. Lets me go up to there. So interesting. So I'm gonna say plus or minus the square root of b squared, which is again this but squared. So I'm gonna write it really tiny. Over squared minus 4. A is just 1 because that's why we got rid of that big coefficient that it was in front, and we did that in the steps that we just showed. So minus 4 times 1, so we're not even going to write times 1, and then times c, which is all of this term. So I guess this is going to be more tricky to write, but that's okay. And then that's AV bar minus RT to the 3/2 times V bar squared plus P square root of T V bar cubed, and then over P square root of T V bar. And then all over 2a, which is 2 times 1 in this case, and that's just 2. Sorry, I'm trying to draw a straight line, but it seems impossible. Okay, right there, all over 2a, which is 2 times 1. So this would be our answer for B. And yes, I think this is, we can further simplify this. I did in my notes, but I feel like this is good enough. Wait a minute. I'm trying to check something. B squared minus 4ac. Oh, right. Okay, so this should be a positive, right? Because minus 4 times AC, which would be times 1 times this negative term. Well, negative times a negative is positive, so it should be plus 4 times all of that. Okay, so that's a good catch. I think that's pretty much it. Yeah, I think you could take this 2 and put it here in front of both of these terms right here, so it's not in the denominator. But other than that, I think it's pretty much all I wanted to review, and I hope this video helps.